Hello, Lovejoy Leopards. Welcome. Y'all go ahead. Y'all make fun of me all day long. I'm just trying to make this entertaining for you guys. Welcome to 2.6 video lesson. All right, so guys, today we are going to be proving certain angle relationships. So you're going to take what you know and you're going to find values that prove that angle relationship is valid. So let's go take a look at what angle relationships we're talking about. Okay, so right here, first thing, and if you guys remember, do you guys remember from 1.6, right? We have the linear pair. Okay, now remember, a linear pair must be adjacent, right? That means they must share a vertex and share a side. They must be supplementary. They always add up to 180 degrees. And here's what a linear pair looks like. Okay, so again, this is review from what we talked about in 1.6. Remember, I told you guys we're going to be using linear pairs and vertical angles all year long. Okay, I know. Y'all go ahead. Keep making fun of me. All right, vertical angles. So if you guys remember, vertical angles right here are created by two intersecting lines. Remember, it's created by the X, right? They're non-adjacent. They share a vertex, but not a side. And vertical angles are always, 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 always congruent. Okay, so right over here is a picture of what the vertical angles might look like. And note it, remember, the vertical angles are opposite of each other, okay? And they are congruent. Okay, so let's go take these properties and we're going to work out a couple of problems together. But before we do that, guys, I am going to work out another one of the algebra review problems with you. I'm going to do letter D with you again. So let's go down to letter D as in dog. See you there in just a second. Okay, y'all, on letter D right here, we are going to have to find a common denominator again, because if you guys look, we have three fractions that all have a y variable in it. That means that we need to find a common denominator between 6, 8, and 12. So what do you guys think? What would be the least common denominator that I should use in order to solve this problem? All right, let's see how you guys did. Did you guys say that 24 is our least common denominator? Okay, I hope so. All right, so let's take a look at this. Oh, if I can get out the right pen, we'll be taking a look at it. All right, so if I want to go to 24, okay, that means 6 times 4 equals 24, which means what I do to the bottom, I got to do to the top. So I'm going to multiply 4 times 5y, right? And then, okay, I'm going to have minus, well, I'm going to have 24 over here too, but let's see, 8 times 3 is 24. So guys, that means I have to multiply this whole thing times 3, because what I do to the bottom, I have to do to the top, okay, equals, and if this thing is over 24, well, 12 times 2 is 24. So I have to multiply everything in the numerator times 2 as well, okay? All right, so now we're going to use our algebra skills and we're going to work through this. All right, I'll go ahead and work through it with you guys. All right, so up here we have 20y minus, now guys, right here, this is a negative 3 that I'm going to distribute. Okay, so negative 3 times 3 is negative 9, right? And then I do the negative 3 times negative y, which negative times a negative is a positive, 3y equals, and then remember, I'm going to distribute over here as well. Okay, so I have 8y plus 6. Okay, now that doesn't look quite as scary, except for the fact that, remember, all of this is over 24 and all of this is over 24. Oh, Miss Smith, why'd you have to put the fractions back in there? Well, guys, because we're dealing with the fractions. So let's start by combining the like terms in the numerator. Okay, so I'm going to combine my like terms up here. So I have 20y plus 3y. So I have 23. My brain is thinking too fast. So 23y minus 9 equals, and this is over 24, equals 8y plus 6 over 24. Now, do you guys remember when I said I said it last time that whenever we have two fractions equal to each other, there's a method that we can use in order to solve this. Anybody remember what that method is? Okay, let's see. Did you say, hey, Miss Smith, we can cross multiply? Yes, we can. Now, when we cross multiply, guys, we're going to be taking 24 times that whole thing. So in order to do that, that's what this is what it looks like. 24 times 8y plus 6. You have to put that whole thing in parentheses. Okay, equals, and then over here, I'm going to be taking this 24 times that whole thing, right? So 24 times 23y minus 9. Okay, now I think from here, you guys can probably solve it on out. I want you guys to go ahead and work it out, and I want you to tell me, what do you guys get for the value of y? All right, so hopefully you guys worked it out, and it came down that y simply equals 1. Can you believe that? Y equals 1. Okay, so let me go ahead and work out the rest of this for those of you that would like to see this. Okay, now, guys, if you notice right here, I've got a 24 on the left-hand side and a 24 on the right-hand side. Well, if I divide both sides by 24, these 24s go away, which makes it really, really nice. Then I end up combining my like terms. So I'm going to move my 8y. So I'm going to subtract 8y, subtract 8y. I'm going to combine and put plus 9 and plus 9. So what I end up with is 15 on this side equals, and then 23 minus 8y is 15y. And guys, 15 divided by 15 is numero uno. Okay. All right, so I'm going to let you guys take a look at that, write that down, make sure that you have that down so that you guys are familiar with it. You can use it for your other algebra review problems, okay? All right, and then next, guys, we're going to go down and we're going to take a look. We're going to go down and look at number 5 together. Number 5 is next. Okay, so in the beginning, do you guys remember when I said that what we're going to do is we're going to take the properties of angle relationships in order to solve some problems, in order to find the value of x and y. Well, guys, if I look at this problem that I have right now, okay, it says over here, I have this picture, and it says find the value of x and y. Well, if I look at my picture over here, I have to ask myself, well, what do I have? What kind of angle relationships do I have over here? So let's look at our variables, and I'm going to highlight some different things. I've got an x value right here, but then I don't have any other x's. Okay, so let's come back to that in just a second. Then I have a y value here and a y value here. Oh, hey guys, for the y value, there is an angle relationship that we've learned about on those y values. What is the angle relationship of those angles that have the y value in them? Right, those are vertical angles. They are opposite of each other. They share a vertex, but not a side. Oh, so right here I have vertical angles, and I'm going to abbreviate VA for vertical angles. And if I have vertical angles, remember the property says they have to be congruent. Okay, so I want you guys to practice this again. Remember, we did this before. If they're congruent, I want you guys to set up the expression, and then I want you to solve for y and tell me, what do you get for the value of y? Okay, let's see how you did. First of all, did you set up the equation that, guys, they are equal to each other? So if they're congruent, we're going to set them equal to each other, and then we're going to combine our like terms. So I move the 2y to the other side. That leaves me with 3y. I move the 14 to the other side, so I add 14 to either side, and that gives me 33. And then when I divide through by 3, y equals 11. Did you guys get 11? Okay. All right. Well, now that we know that y is 11, hey guys, we're going to go back and we're going to come over here to our picture, and we're actually going to plug in 11. Okay, we're going to plug in 11. So for right here, okay, and I'm going to point to it, I would do 5 times 11 minus 14. Okay, and I'm going to plug that in. And that gives me that this angle over here is 41 degrees, which if they're equal, that means that this one is 41 degrees. Okay, now that I have that information, guys, now we can look and see, okay, now we can solve for x. Okay, so I'm going to ask you guys, this x angle right here, excuse me, this angle that has x in it, what relationship does it have to either of the 41 degree angles? What do you guys think? What is that relationship? Okay, so here's my hope. My hope is that you guys recognize that, you know what? These angles are on a line and they are adjacent. So that means that the 5x plus 10 and the 41 degrees, hey guys, they're a linear pair, right? They're adjacent. And oh, a linear pair means that, oh, they add up to 180. They're supplementary, aren't they? Okay, they're supplementary. Okay, so having said that, I want you guys to set up the equation for the x value, and I want you to solve it and tell me, what do you get for the value of x? Okay, let's see how you guys did. Did you set it up correctly? If they're linear pairs, they add up to 180. So this angle plus this angle, we add those together and they add up to 180. Okay, so once we combine like terms, we have 5x plus 51 equals 180. We subtract 51 from both sides, so we have 5x equals 129. And then once we divide through, hey guys, you're going to get 25.8. Yes, your answer can be a decimal, right? So x is 25.8. Okay, so guys, not all of your answers are going to be whole numbers. Expect that some of your answers will have decimals in them. Okay, excuse me, guys. So if you guys noticed, one of the things that I did here is that I wrote down, okay, what the angle relationships were and what their property is. Remember I told you guys before that you're going to have to start saying which angle relationship did you use. You're going to have to prove it, okay? All right, so I tell you guys what. We're going to go down to number 7, and I'm going to talk to you guys about just setting it up, and then I'm going to let you work it out. Let's go down and take a look at number 7. All right, so on number 7 right here, we're looking at, it says find the value of x, and we've got this picture over here. Well, guys, now, we only have one variable, x, but if you guys notice, I've got x in every single expression. So what should we do? Well, guys, in an instance like this, guys, you get to choose which angle relationship makes the best sense for you to solve. Do you prefer using the relationship of linear pairs, or do you prefer using the relationship of vertical angles? And then in chapter 3, you're going to see there's even more relationships. But right now, we're just dealing with linear pairs and vertical angles. So guys, you use whatever method you prefer that works best for you. Set it up, show your work, make sure you write down which relationship did you use. Just write it down, okay? And we'll see if you're on the right track when you go to do corrections on your work. Okay, guys, that is it for the Unit 2, Section 6 video. So, guys, as usual, if you have questions, please, please, please make sure that you talk to your teacher, ask your teacher about it, ask your neighbor about it, ask your tutor about it. I want to make sure that before we jump into Unit 3, that you guys are comfortable with the vocabulary from Unit 1 and Unit 2 and know what everything means and how to use those properties. Okay, because we're going to have a lot more vocabulary come in. We're going to have a lot of different problems, and actually it's a lot of fun. And we're actually going to do a project. Yay! All right, guys, until then, I'll see you later. Adios!